The story begins inside the most complex place we know, 86 billion neurons, trillions of connections, a living galaxy of thought, memory, and feeling. For Maya, the first clue is small, a new morning headache that fades, a brief blur in her vision, a word that won't arrive. Hidden in this intricate network, not an invader from outside, but glial cells gone astray. Astrocytes forgetting their rules. This is glioblastoma, the most common and most aggressive primary brain tumor in adults. It grows from the very cells meant to support and protect our neurons. Under a microscope it looks wild and varied, multiform, because the tumor evolves quickly, adapting, changing its shape and behavior. It is a rebellion from within the brain's own architecture, and naming it is the first step to facing it. Glioblastoma rarely forms neat borders. It moves fast and infiltrates, sending out microscopic threads that weave through healthy pathways like roots through soil. On scans, surgeons can see a dense, bright core, but the single-cell extensions often travel beyond what the eye can catch. Even after a skilled operation, those hidden cells can remain, ready to grow again. This is why surgery alone is seldom a cure, and why the surgeon walks a tightrope. Remove as much as possible while protecting speech, movement, memory, everything that makes a person themselves. The battle is not against a single lump, but against a diffuse network of malignant cells blended into the brain. Early symptoms can be subtle. Watch for new or worsening headaches, often worse in the morning and not relieved by usual medications. Seizures are common, sometimes dramatic, sometimes a small hand twitch or a brief spell of confusion. As the tumor touches specific regions, weakness or numbness on one side, trouble walking, or difficulty holding objects can appear. Words may slur, or the right word may hide. Vision can blur, or the edges of sight can fade. Changes in memory, personality, or focus may be noticed first by family. And some signs are emergencies, a sudden severe headache, repeated vomiting, or new uncontrolled seizures. If these happen, go to the emergency room immediately. Diagnosis starts with an MRI of the brain with and without contrast. Often, glioblastoma appears as a bright ring surrounding a darker center. Active tumor around a necrotic core. Suggestive, yes, but the final word comes from tissue, a biopsy or surgery examined by a neuropathologist. Today, we go deeper. Ask for comprehensive molecular testing of the tumor. These markers help guide care. IDH status, MGMT promoter methylation, EGFR amplification, and TERT promoter mutation. Most glioblastomas are IDH wild type and behave more aggressively. MGMT methylation, if present, predicts a better response to temozolomide. These details don't define the person, but they shape a smarter plan. The standard path is a coordinated sequence. Step 1. Maximal safe resection. Take what can be taken while protecting who Maya is. Next comes 6 weeks of radiation, precisely targeted, about 60 gray, given together with a daily low dose of temozolomide. After that, cycles continue. 5 days of higher dose pills each month for at least 6 months, sometimes longer. Along the way, steroids like dexamethasone reduce swelling to ease headaches and neurological symptoms. Anti-seizure medicines are used when seizures have occurred. Each piece has a purpose, and together they make a strong foundation. Beyond the standard, innovation widens the path. Tumor-treating fields use physics instead of drugs. A wearable device delivers low-intensity, alternating electric fields through arrays on the scalp. When a cancer cell tries to divide, the mitotic spindle falters, the split fails, and growth slows. Clinical trials have shown added survival when this is combined with standard therapy. Another hurdle is the blood-brain barrier. It protects the brain, but it also blocks many medicines. Focused ultrasound can temporarily open tiny pores, letting targeted therapies reach the tumor in higher concentrations. Then, the barrier closes again. Step by step, new tools are opening doors. Even with excellent care, glioblastoma often returns. Then the plan is personal. If the tumor is accessible, a second surgery may help. In select cases, a measured second course of radiation can be considered. Other chemotherapies, like lomustine, may be used. Bevacizumab can reduce swelling and improve symptoms, even if its effect on overall survival is limited. At recurrence, clinical trials become a key avenue of hope. Oncolytic viruses that expose the tumor to the immune system, CAR T cells engineered to recognize it, and targeted drugs designed to cross the barrier and shut down its drivers. The goal is to match the right tool to the right tumor. Prognosis varies by many factors: age, overall and neurological function, how much tumor was removed, and the molecular profile, especially MGMT status. Median survival with standard therapy is about 14 to 18 months, but medians describe groups, not individuals, and some people live much longer. If this were my journey, I would act quickly and calmly. Get an MRI with contrast. Meet a neurosurgeon and a neuro-oncologist at a high-volume center. Ensure comprehensive molecular profiling. Discuss surgery, radiation with temozolomide, and the role of tumor-treating fields. I would ask for supportive care from the start: physical and occupational therapy, speech and cognitive support, and palliative care focused on quality of life. At recurrence, I would review trials and welcome a second opinion. This is a hard story, and it is also a human one. With science, a dedicated team, and steady steps, light returns to the network. You are not alone. One decision, then the next. Hope, anchored to action.